Hello, everyone. My name is Tobias, and for the past 6 weeks, I've been working with the R&D team at faculty. AI can do some amazing stuff. Here we see an image of AI detecting cancer in real time. The best models outperform humans at a fraction of the cost. But AI also gets things wrong. For instance, it sometimes sees things that aren't there. Here's a picture of some bugs. The model predicts it is a dog. Why? Well, it sees a dog on the left-hand side of the picture. Similarly, here is an image of some fish. The model predicts it is a frog. Why? Well, it sees the fish as the eye of a frog. AI can also make mistakes because it doesn't completely understand what it is looking for. Here we have some concentric brown circles that the model thinks is a bagel, or some patterns that the model thinks is a baseball. You and me can tell that these things are not the real thing, but the model can't. AI can also be wrong because it has to make a prediction on whatever kind of data we give it, even data that has no content. But it is even worse. The model confidence for all the previous predictions are over 99%. So not only is the model wrong, it is really confident that it is right. The goal of my project is knowing when AI doesn't know. Here's what we did, illustrated by an analogy. Say that I'm on Netflix. They recommend me the movie Get Santa. Well, the question is, will I like that movie? They think I'll enjoy it, but can I trust their prediction? How could we know? Well, one thing we could do is we could look at previous recommendations for similar movies and see how good they were. Here you see the accuracy for Netflix recommendations on Christmas movies. Turns out I hated all their recommendations, except Polar Express, which is my favorite movie. But what does it mean for two movies to be similar? It might not be the right thing just to compare genres. Or for instance, would you say that two movies are more similar if they have the same director but different cast? Or more similar if they have the same cast but different directors? What we need is a principled way of measuring similarity between movies. How we do that is we use a variational autoencoder to learn an abstract representation of our movies in an encoded space. So every point in the encoded space corresponds to a movie. And we can use closeness between points to measure similarity between movies. So let's say we have a new prediction. What we do is we identify the nearby points, which correspond to previous predictions, and compute some statistics related to the model performance on these points, and then use these statistics to evaluate whether we want to trust the model or not. For example, Netflix recommends me Lord of the Rings. In the past, it has recommended me quite a few fantasy movies, of which many I didn't like, so I should probably be skeptical about the new prediction. Another example, if I have few data points, then I shouldn't make any strong conclusions at all. Netflix recommends me Love Actually. Well, I liked all the romantic comedies that it has recommended me before, but since I haven't seen very many, I shouldn't be too confident about this prediction. Lastly, if I have many similar points and a good model performance, I should probably trust the new prediction. For instance, Netflix recommends me 00 Schneider. From all previous recommendations for German comedies, I found to be excellent. Therefore, I will probably like this one too. But how well does this idea perform in practice? This graph compares my credibility score with model accuracy for test points that have the same credibility score. You can see that credibility is very closely related to model accuracy. Since it is a good model, I very rarely observe low credibility, which is reflected by the high uncertainty on the left-hand side. On the right-hand side, for high credibility points, I have much more certainty and high accuracy. So effectively, I found a way to determine whether I can trust my model or not. But it is even better. We can look at model performance of proportions of the data with highest credibility. This is what this graph shows. For example, if we include all our data, what we receive is just the model accuracy. In this case, 91.5%. But if we consider 85% of the data with highest credibility, we receive already a model accuracy of over 95%. And lastly, on the 30% of the data with highest credibility, I get a model accuracy of over 99%. So effectively, we can use my credibility score to decide when I should pass a prediction to a human for verification and be sure to have an improved accuracy on the remaining ones. So what's the impact of my work? I've developed a way to decide when I can trust AI using a credibility score. And I found a way of prioritizing for human intervention in cases where I have low credibility. If anybody has some questions, please approach me in the break. Thank you.